The H-20 is China's most advanced bomber project to date and represents a significant evolution in the country's strategic aviation capabilities. It is being developed to fulfill the long-standing goal of having a modern, long-range stealth bomber that can project power far beyond China's borders. Until now, China has relied primarily on the H-6 bomber family, which is based on a 1950s Soviet design. While upgraded over the years, the H-6 remains a medium-range, non-stealth aircraft with limited survivability in a modern high-threat environment. The H-20 is intended to replace this aging platform in the strategic bomber role and to elevate China's air force to a new level of operational reach and deterrence. The H-20 is being developed by Xi'an Aircraft Industrial Corporation, which has a long history of working on Chinese bomber programs. It is part of a broader trend in Chinese military modernization that includes upgrades across all branches of the armed forces, with particular emphasis on expanding power projection capabilities. The H-20 fits into this trend as a high-end asset that would give China a credible long-range strike capability for the first time. This would be particularly important for scenarios where targets are located far from China's borders and may be defended by advanced air defense networks. A core feature of the H-20 is its emphasis on stealth. Stealth is achieved through a combination of airframe shape, engine configuration, internal weapon storage, and radar-absorbent materials. The aircraft is believed to have a flying wing design, which inherently supports low radar visibility. This design eliminates vertical tail surfaces and creates a smooth, wide platform that reflects less radar energy. The engines are likely buried within the wing structure or shielded with special ducts to minimize both radar and infrared signatures. The overall goal is to allow the aircraft to fly into contested airspace, carry out its mission, and exit without detection or interception. The bomber's mission is strategic in nature, which means it is designed to attack high-value, distant targets. These might include military infrastructure, command and control facilities, transportation hubs, air bases, or other key components of a potential adversary's operational capacity. The H-20 is expected to be capable of delivering both conventional and nuclear payloads, which would make it a flexible platform within China's strategic doctrine. With this dual capability, the H-20 would join China's land-based missile forces and submarine-launched ballistic missile capabilities as part of a diversified strategic deterrent. Estimates of the H-20's range place it well above 8,000 kilometers, which would allow it to strike targets across large portions of the Indo-Pacific region and beyond without aerial refueling. This is a substantial improvement over the H-6 series, which is largely limited to operations near China's coastline unless supported by tankers. The ability to fly deep strike missions without relying on vulnerable support infrastructure increases the bomber's effectiveness and survivability. It also makes the H-20 a more flexible tool for strategic signaling and deterrence, allowing it to remain in the air longer and reach targets previously out of range. The internal weapons bay is likely to be designed for standoff weapons, such as long-range cruise missiles and precision-guided munitions. These weapons could be launched from hundreds or even thousands of kilometers away from the target, further reducing the bomber's exposure to enemy defenses. The internal bay configuration is necessary to maintain the aircraft's stealth profile, as mounting weapons externally would compromise low observability. The H-20 may also carry future generation munitions, including hypersonic glide vehicles or advanced air-launched systems, though this remains speculative. Another critical area of development is the aircraft's onboard systems. A modern stealth bomber requires advanced avionics, including radar warning receivers, electronic countermeasures, and multispectral sensors. These systems would help the bomber detect threats, navigate complex environments, and communicate securely with command authorities over great distances. The H-20 is expected to feature data fusion technologies, which combine information from multiple sensors into a single operational picture, enabling faster and more informed decision-making by the crew. The aircraft will also need to operate with a high degree of autonomy or semi-autonomy. As global airspaces become more contested and communications more vulnerable to interference, future bombers must be capable of completing missions even in environments where real-time communication is degraded or unavailable. This may include the use of pre-programmed mission profiles, onboard artificial intelligence for threat recognition, and redundant systems for navigation and targeting. From a strategic planning perspective, the development of the H-20 reflects China's intention to transition from a regionally focused military to one that is capable of operating globally when necessary. The bomber would provide a new option for deterrence and retaliation in the event of a major conflict. It also allows for greater flexibility in crisis situations, where the mere movement or deployment of the aircraft could serve as a form of strategic messaging or pressure. The psychological effect of knowing that an adversary possesses stealth bombers capable of reaching sensitive targets across vast distances should not be underestimated. Despite its strategic role, the H-20 is not expected to be produced in large numbers, at least initially. Strategic bombers are expensive to build and operate, and their missions are typically limited to high-end scenarios rather than daily tactical operations. However, even a small fleet of H-20s would be enough to shift strategic calculations, particularly if the aircraft are equipped with powerful munitions and supported by a network of enabling assets, such as intelligence, surveillance, and reconnaissance systems. The development process for a bomber of this complexity is long and highly technical. It requires coordination across many areas of industry and technology, including metallurgy, materials science, avionics, propulsion, software engineering, and weapons integration. China's investment in these sectors over the past 2 decades suggests that it is now capable of undertaking such an advanced project, but challenges remain. For instance, developing reliable and stealthy engines suitable for long-range operations has historically been a difficult area for Chinese aviation. Whether the H-20 will rely on a new engine developed specifically for the bomber, or on an improved version of an existing one, remains unclear. Flight testing, which is likely already underway or imminent, will be a crucial phase. Test flights help validate the aircraft's aerodynamic performance, structural durability, radar signature, and onboard systems. They also provide data for software refinement, system integration, and crew training. This phase can last several years depending on the complexity of the aircraft and the number of problems encountered. Even after successful testing, transitioning the bomber into operational service will require training, infrastructure development, and the establishment of maintenance and logistics systems. In terms of future prospects, the H-20 could serve as the foundation for a broader family of stealth aircraft. Lessons learned from the bomber's development may be applied to future unmanned systems, support aircraft, or tactical bombers. Additionally, technologies pioneered for the H-20, such as flight control software, stealth coatings, and radar systems, could influence the design of next-generation fighter aircraft or drones. Overall, the H-20 represents a major leap in capability for the Chinese Air Force. It marks the transition from a force that primarily defends its own airspace and nearby seas to one that can project credible strike power over long distances with a reduced risk of interception. This transformation has implications not only for the balance of military power in the Asia-Pacific region, but also for global security dynamics. The bomber's development signals that China is seeking to develop tools not just for regional influence, but for global reach and strategic depth. While many specifics remain unconfirmed and the timeline for operational readiness is still uncertain, the overall trajectory of the H-20 project reflects China's increasing technological confidence and its ambition to reshape the strategic landscape. Once operational, the bomber will likely become one of the most important assets in China's military, shaping its doctrine, deterrence posture, and power projection strategy for decades to come.